Today we are starting Chapter 3, which talks all about solving inequalities. Please take note that the corresponding iBook pages are in the top right corner. So let's start with Lesson 3.1. The objective of this lesson is for you guys to be able to write, graph, and identify solutions of inequalities. The only vocab that goes along with this lesson is the solution of an inequality, which is any value or values of a variable in the inequality that makes it true. So first, let's talk about what an inequality is. An inequality is a math sentence that uses those inequality symbols to compare the values of two expressions. We use number lines to visually represent the values that satisfy an inequality, or the solution of an inequality. At the bottom of the page, you will find the inequality symbols. This first one represents greater than. The second one is less than. The third one is greater than or equal to. And the last one is less than or equal to. Notice how the bottom two have this bar underneath the symbol. That is what tells us we have this attached equal to our inequality. So here we're going to start with word phrases. If we look at the first one, and I say that all real numbers x less than or equal to -7, and I want to use this word phrase to write an inequality, where do I start? Well, if we look at the word phrase, it tells us that x represents all real numbers. So I'm going to start with my x. It also tells us that x is less than or equal to. So I do my less than or equal to inequality symbol. And last but not least, it tells us that these real numbers x are less than or equal to -7. So my inequality to represent this first word phrase is written as you see here. X is less than or equal to -7. Let's look at number 2. It says 6 less than a number k is greater than 13. So here we've added on a step. 6 less than a number k. How do I represent that? Well, k subtract 6 is greater than, so I'm going to do my greater than symbol, 13. So this word phrase is represented by k minus 6 is greater than 13. Okay, so now that we've practiced writing inequalities, I want to see if I can identify a solution. So the inequality that is given here is 2x plus 1 is greater than -3. For the first problem, they want to know if -3 is a solution to this inequality. So what you can do is actually plug in -3 for x. So 2 multiplied by -3 plus 1 is greater than -3. What we want to do is see with this -3 plugged into x if this inequality is true. So -2 times -3 will give us -6 plus 1 is greater than -3. Well, -6 plus 1 will leave us with -5 greater than -3. So what I want to do is see if this part is true. Is -5 greater than -3? No, it is not. Therefore, -3 is not a solution. Okay, we want our inequality to be true if it is a solution. So let's look at the second one. All I'm going to do again is plug in -1 for x. So 2 multiplied by -1 plus 1 is greater than -3. Well, 2 times -1 will give me -2 plus 1 greater than -3. I know that -2 plus 1 will leave me with -1 greater than -3. Again, is this true? Well, -1 is greater than -3. So yes, -1 is a solution. In the beginning of this presentation, I told you that we use number lines to visually represent solutions of an inequality. So that's what we're going to do here. And if we look at this first one, it says that n is less than -1. The way I can use a number line is to start by drawing it, okay? It says that n is less than 1, so I'm going to put a circle above 1, and I'm going to draw a line going towards the left of the number line. This is a number line that can represent all of the solutions to n is less than 1. Okay? Let's look at number 2. Start by drawing my number line. Okay? 0, 1, 2, 3. I'm going to put some negatives on there. Okay. Here we see that a is greater than or equal to 0. So my line is going to go above 0. And this time I'm going to have a line going to the right on the number line. Okay. Because I have this greater than or equal to 0, I'm actually going to fill in this circle. Okay. Because let's think about this. If a is greater than or equal to 0, that means that 0 is also a solution to the inequality, and that's why we shade in this circle. But if we look up here at the first example, notice how my circle is not shaded, okay? It's left open. That's because n is less than -1. That means n cannot be 1, okay? Let's look at number 3. F is greater than -3. I'm going to start with my number line. Did I say less than? I meant F is greater than -3. All right, let's draw it out. And I'm going to squeeze -3 in here. Okay, if F is greater than -3, I'm going to have my circle above -3, and because it's greater than, I'm going to the right on the number line. Let's look at the last one, number 4. This one is written a little differently, but I don't want you to get confused by it. It says that -2 is greater than or equal to x. So notice in all the examples we did above, the variables were on the left side of the inequality symbol, and this time my x is on the right side. It's okay, we can still do it. So let's draw our number line out. Okay. If -2 is greater than or equal to x, I'm going to have a filled in circle over 2. And because it's greater than or equal to, I am actually going to go to the left. Now let me explain this. If you look down here, I tell you that you can also write -2 is greater than or equal to x, as x is less than or equal to -2. Okay? If x is less than or equal to -2, that's why we go to the left on the number line. So these are the same exact inequality. They're just written in 2 different ways. So here we just have another example of how to write a graph for an inequality. If I am given 2 is, whoops, sorry, that got a little crazy. 2 is greater than or equal to a. I can also write that, remember, as a is less than or equal to 2. Okay? So I'll start with my number line. 0, 1, 2, 3. Include some negatives. Okay, since a is less than or equal to 2, I'm going to put a closed in circle over 2, because remember 2 can be a solution, and I'm going to go to the left of the number line. Are you guys still with me? I hope so, because we're almost done, I promise. Just hang in there. Okay, so this page really wants us to be able to write inequalities based off of a number line given. So if we look at number 1, we see that we have a shade and circle. So that should be our first indication that it's going to be something or equal to. okay? I'm going to start by writing my variable, and I'm just picking x, but you could use anything really. I know that my line on the number line is going to the right. Therefore, x has to be greater than, and because I have this shade and circle, or equal to, and it looks like it's at -1. So this inequality would look like x is greater than or equal to -1. Let's look at number 2. Here, it's important to notice that we have an open circle, or it's not shaded in, and my line is going to the left, which means x is going to be less than or equal to, and it's right at 3, so that's going to be my other part. X is less than or equal to 3. Here we have word problems, which I know are all of your guys' favorites. The first one says that trail rides start at $19.99. Because trail rides start at $19.99, I know that that means they can be more expensive, okay? So I'm actually going to say that x is greater than or equal to $19.99, meaning x can be $19.99, right? You can get a trail for $19.99, or it might be greater than, it might be more. Maybe it depends on how far you go, how many people you have, something like that, okay? So the inequality you see here, x is greater than or equal to $19.99, would be an inequality to represent the first mini word problem. So let's look at number 2. The speed limit is 25 miles per hour. Okay, if that's my limit, that means I can't go any faster than 25 miles per hour. So here we're actually going to say that x is less than or equal to 25, right? Because if my limit's 25, I can't go any faster, meaning I'll have to go less than or equal to 25. So these are just 2 real-world examples of how we can use inequalities. Before I let you off the hook for the night, I want to go over a couple examples, so feel free to grab a piece of paper and a pencil and try them along with me. The first one is basically using a word phrase, and it wants us to give an inequality or a math sentence. So it says, what algebraic expression represents all real numbers y that are greater than or equal to 12? So I know I'm using y simply because the problem tells me, so I'll put y. It also tells me that y is greater than or equal to, so I'm going to do my greater than or equal to symbol, and here we have 12. So simple as that. Y is greater than or equal to 12. All right, let's shift down to number 2. Is -1 a solution to 6x minus 3 is greater than or equal to 10? What about 0? Let's start with -1. Remember, this is where you just plug it in for x and see if the inequality is true. If 6 multiplied by -1 gives us -6, and we're subtracting 3, I'm going to be left with what? -9 is greater than or equal to 10? That is false, right? That is not true. So that means that -1 is not a solution. I'm running out of room, but maybe I can slide this up. Yeah, I can slide it up and we can talk about 0 being a solution. Okay, so again, I'm just going to plug 0 in for x. 6 times 0 is 0. Carry everything down. 0 minus 3 will just be left with -3 is greater than or equal to -10. I know that that is false. Because it's false and not true, that means that 0 is not a solution. So neither of these examples were solutions because your inequality is not true. All right, let's look at number 3. What is the graph of 2 is greater than p? So here we're just going to do our number lines. Okay, 0, 1, 2, 3, include some negatives. Whoa, I don't know what happened. Okay. Because 2 is greater than P, I can also write that as P is less than 2. Okay, because it's less than 2, I'm going to do an open circle, and I'm going to go to the left of the number line. Remember, it's not shaded in because it's not equal to. Okay? And last but not least, if we look at number 4, it wants to know what inequality represents the number line you see there. So I'm just going to pick X, okay? Because it's going to the left of the number line, right? It's going this way and it's shaded in. I know that X has to be less than or equal to, and it's at -1. So X is less than or equal to -1. We will go over more of the inequality stuff tomorrow, or the next time I see you. But please remember that you can rewatch this if you have any questions. You should. If you do have any questions, make sure to jot them down and bring them to class the next time I see you. And we will continue with this another day.